Hello everyone, my name is Rohit Singhal and we were discussing about the topic hydrocarbons. In the previous classes we have discussed about the alkenes, we have discussed about its physical properties, about the synthetic procedures to synthesize the alkenes. We have then started with the chemical properties of it, we have discussed a few, and in this lecture and onwards we will continue from the where we have left the chemical properties. So, let us continue where we left from. The topic we were discussing, the subtopic is chemical properties of alkenes. Till now we have discussed the few properties, and that were, first we have discussed the addition of hydrogens, it is a hydrogenation reaction. Then we have discussed addition of halogen, that means halogenation reaction, and then which we were discussing in the previous lecture was addition of hydrogen halide, that is HX addition. What we have discussed till now, that addition to an alkene of hydrogen halide will form an alkyl halide. As this alkene is a symmetrical alkene, so it does not matter on which carbon the hydrogen is going and on which carbon the halide is going to attach. But if we take an example of unsymmetrical alkene, which we have also discussed, the two products can be think of, and the two are either the bromine is going to attach on one carbon, hydrogen on the another, and vice versa, and in both the cases both the products will be different. In one case we are forming 2 bromopropane and it is 3 bromopropanes, means 2 products can be formed which are actually the isomers of each other. In the previous class I have discussed that which will be the major product. I have discussed why 2 bromopropane is the major product in this reaction, and that has been stated by Markonikov's rule. What we have studied, because the reason is Markonikov rule, and why the reason of the stability of this more stable 2 bromopropane is the formation of stable secondary carbocation in the formation of okay. So, if you remember, we have discussed in the previous class that due to the Markonikov's addition, this is so because the Markonikov's addition, we have discussed the mechanism that the reaction proceeds via the formation of a carbocation, and in the two cases possible, the 2 bromopropane and 3 bromopropane, the 2 bromopropane involves a formation of a secondary carbocation, and the 3 bromopropane, oh sorry, not 3 bromopropane, it is 1 bromopropane. A 1 bromopropane involves the formation of a primary carbocation, and secondary carbocation is more stable than the primary carbocation due to the inductive effect. That is why if the intermediate is stable, the reaction will tend to go in that direction. That is why 2 bromopropane is the major product. Now, there is a question that can be asked, that can be arise in your mind also, that what if we need one bromopropane as the major product. So, is this possible can we achieve it, and if it is possible, then how we can achieve it. So, yes, there is a way we can do it. Yes, we can do, and the rule, and by which the rule we can say is, we have studied till now is Markonikov's, right? Markonikov's, and now this rule will follow Anti-Markovnikov's addition, or it is also known as peroxide effect. Okay. So, what does these steps involve, or it can also be known as crash effect, that is also known as okay. Okay. Now, I have stated these big names. Now we will see how what this rule actually states, and how we can form the other product, which one is 1 bromopropane as the major product than the other one. Okay. So, let us see what we have to do in such cases. Till now what we are doing is we were adding HBr, right. Yes, we have to add HBr also, and we were proceeding with the reaction. Now, what we will do, we will add some peroxide into it. We will add a peroxide. The peroxide we will normally use is C6H5 and this is known as benzoyl peroxide. Okay. What a peroxide is? Peroxide means O single bond O. O single bond O is known as peroxide. Okay. So, what does this benzoyl peroxide structure is? It is C6H5 1 benzene, then C double bond O, 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 C double bond O, C6H5. So, this is the structure of benzoyl peroxide, where there is a OO single bond linkage. Whichever molecule have a OO single bond linkage, those molecule are considered to be have a peroxide linkage. That linkage is known as peroxide linkage. That peroxide in this case is creating such some effect, which is going to produce the 1 bromopropane as the major product, and we will discuss how this peroxide is creating this 1 bromopropane as the major product. Although the second product is also formed, it is not that 2 bromopropane is completely not formed, it is formed, but it is a minor amount, very less amount. The majority of the product is 1 bromopropane, whereas in the Markonikov's addition 2 bromopropane was the major product, and in the anti-Markonikov's production the 1 bromopropane is major product. Now, we will see what this peroxide is doing to create such a fact that 1 bromopropane is having a major product as compared to the 2 bromopropane. So, let us discuss what this peroxide is doing. Now, we will discuss that what this peroxide is doing, what is the role of peroxide, that due to it the other product is being the major one. So, what this peroxide does, it proceeds the reaction, via free radical chain mechanism. And we have discussed what free radical chain mechanism. Free radical chain mechanism involves 3 major steps. First one is initiation. What does the initiation step is? Initiation step means the generation of the radical. The other step is propagation. Propagation means the radical is being used and the chain is elongating, and the third step is termination. Okay. So, let us discuss one by one. Step 1 initiation. What does these initiation steps do? What we have? We have peroxide. Okay. So, what does this peroxide does? C6H5, C double bond O, C double bond O, C6H5. Now, one thing you should keep in mind that O single bond O, that means peroxide linkage, is a very weak bond and it can cleave easily. Normally, it gives the homolytic cleavage, means the bond is equally separated and give the free radical. In some cases, it can also give the cation or anion, but oxygen oxygen bond, the peroxide linkage is a weak bond. So, you must remember this oxygen oxygen peroxide linkage, this peroxide linkage is weak. So, what happens? This bond cleaves, and after the cleavage, what this bond gives? Oxygen radical. Okay, we all know that oxygen already contains 4 electrons, right? Two lone pair of electrons oxygen already contains. So, oxygen have 2 lone pair of electrons, 1 extra electron is added. So, what does it form? There are already 2 lone pair of electrons, and this radical formation, 1 radical is formed, okay, represented by the half arrows. Okay. Now, what happens is this radical on the oxygen is not very stable. So, what happens is it wants to what? Remove out from the molecule. So, how it does so to get stabilized is, we have a bond here. Okay. What does this CC bond breaks and gives us the CO2. CO2 gas is released and gives us a C6H5 radical, that means benzyl radical. Okay. Benzyl radical it gives. So, by removal of the carbon dioxide, you must be wondering why the benzyl radical is being formed. Do remember one thing in chemistry, that the removal of any gas in the reaction enhances the reaction, means if any reaction involves the removal of any gas, the reaction is favorable. Okay. So, this reaction is favorable as it is releasing a carbon dioxide gas. So, the formation of radical. So, this radical is being formed here. The carbon dioxide is released and C6H5 radical is formed. Okay. Now, we will live with the C6H5 radical, benzyl radical. Now, what this benzyl radical does, this benzyl radical reacts with HBr. HBr is also not a very strong bond, because H is a smaller cation, Br is a very big anion. So, the HBr bond also is not very strong. So, what this radical does is, this radical initiates this reaction and it takes up the proton, forms C6H6, that is benzene, and it forms a Br radical. Okay. Now, this steps gives us the radical which we require, the bromine radical, which will be used up in the propagation step. Now, the step 2, propagation. What does the step 2 does? It will react with alkene, the Br radical will react. Now, again this can lead to the 2 different steps possible. Okay. 2 different steps. What is, we know that the alkene bond will be homolytic cleavage, we are discussing about, this reaction is going via radical mechanism, right. So, the double bond will cleave homolytically and it will give the radicals. Now, the 2 things are possible, that the Br radical can go on the center carbon and the Br radical can go on the extreme carbon. Now, again depending on 2 situations, the 2 products can be feasible. Now, we will see that which one will be the major product and why. Okay. So, let us follow that Br radical goes on the center carbon. Okay. If it is so, this will leave up with the radical of this, and if the Br radical goes on the extreme carbon, then this will be remain as the radical, the center carbon, and it will take up the bromide. Okay. So, this will be the intermediate. Remember, in Markonikov's reaction, Markovnikov's addition, we have carbocations as the intermediate, while in this anti-Markovnikov's addition we have radicals as an intermediate. What we have? Radicals as the intermediates. Okay. If radicals are the intermediates, now we know this is a secondary radical and this one is the primary radical. Again it is now that the secondary radical is more stable than the primary radical. Okay. The secondary radicals are more stable than the primary radical. That means, and if the intermediate, these radicals are more stable, the intermediate is more stable, the reaction will be favored in that direction. That means, now the secondary reaction is more stable. Now, what will happen? Now, this will take up the proton. How it will take up the proton? CH3 CH radical is there, CH2Br. Now, it will react with HBr. One radical is initiating or enhancing proceeding the formation of radicals through the another molecule, that is the propagation step, right. So, what it will do is now it will take up the radical and it will form CH3 CH2 CH2Br, that means 1 bromopropane and leaves us with the bromide radical. Again this bromide radical is been left out, and this bromide radical can be used again and again and again by other alkene moieties. So, that is how this step is this step continues, and this is known as the propagation steps. Also, it is not that the other radical will not take up the proton, this will also take up the proton in the same manner, and a 2 bromopropane moiety will be formed, bromide radical will be formed 2 bromopropane, but this will be the major one, sorry, the minor one, and this one will be the 1 bromopropane as the major one, and this is the minor one. And we know how about the third step is termination. We have formed a Br radical, the Br radical can combine with Br radical to give Br2. Also, we have formed H radical in the reactions, it can be possible, it can again form a HBr. Okay. So, we have discussed why and how we can produce 1 bromopropane as the major product, then the 2 bromopropane. If we have to add, if we need to make 2 bromopropane as the major product, then we need to go to the Markonikov's addition and the carbocation formation, and that is how it will give. And if we need the other product to be the major one, we will have to proceed the peroxide effect. What the peroxide effect does? It proceeds the reaction via the chain free radical chain mechanism, and free radical chain mechanism it gives the other product as the major one. The reaction proceeds via the formation of the free radical as the intermediate. Okay. So, that we have discussed. Now, we will discuss further about more chemical properties of it in the further lectures. Thank you so much.